Hi guys, and welcome back to my channel. In today's video we're going to be looking at the ray diagrams which are needed to be known by you for taking up the IGCSE exams, board exams to be specific, and there are 6 cases which you need to know thoroughly to be able to answer any questions on ray diagrams in light. So let's get started. Let's look at the first image. Now in this first image, the light is coming from infinity. Now infinity does not actually mean infinity over here, but that's what it's generally referred to as. Now this actually means that light is being emitted from an object which is far away from you. For example, if you're sitting in front of your laptop, there's a tree behind you. Now that would be your infinity. So you can see that the light comes parallelly if it's infinity, and there is a rule that if light rays travel parallelly to the principal axis, they will have to pass through the focus, which means they'll go through this point, and similarly this ray will go through this point. And you can see that the image is very small over here. So we can call this a highly diminished image or a point size image. Since this image is formed towards the right of the lens rather than the left of the lens, we know that this image is real and inverted and is formed at F. Now you always need to know 3 things in a ray diagram, which is N, P, S: the nature, the position, and the size, which is what they can ask you in your examination. Let's move on to case number 2, when the object is beyond 2F. Now, if the object is beyond 2F, as we all know, like I mentioned earlier, if light rays are traveling parallel to the principal axis, they will converge through point F or point focus. And the other light ray from the tip of the arrow must be taken through the optical center, and the point at which both these rays converge is where the image is formed. As you can see in this, the image is not point-sized, but it is diminished. It's not enlarged, as you can see in the diagram. Now there are 2 rules that you must remember. There will always be 2 light rays coming from the top of the arrow. One will go parallelly to the principal axis and converge through the focus, and the other one will go directly through the optical center of the lens. Now this is the optical center of the lens. Case number 3. The object has now moved from beyond 2F to on 2F. Now over here, again as we saw earlier, there's one light ray going parallel to the principal axis and another light ray converging through F. And there's another light ray going through point O, or the origin. Now in this case, the image is the same size as the object. Let's look at the NPS now. The nature of the image is real and inverted. As you can see over here, the arrowhead is down. The position of the image is at 2F, and the size of the image, it's the same size. Now they might or might not ask you this question in the paper, but you definitely need to know about the rays and how they move. That's very, very important. Going on to the next case, the object is in between F and 2F. Now what happens over here is we're going to again draw 2 light rays. Now you tell me how it goes. Think about it. Pause the video. Alright, so the one light ray goes parallel to the principal axis and goes through the focus, while the other directly goes through the optical center. As you can see in this image, the image is bigger than that of the object, so we can say it's an enlarged image. Let's look at the NPS, the nature, real and inverted. As you can see, the arrowhead is at the bottom here and at the top over here. Position is beyond 2F, and size is enlarged, because you can see, you can actually compare it. This is smaller than this one. Moving on, object at point F. Now let's look at this image. You're still going to draw the same light rays parallel to the principal axis, and after it touches the lens, it converges into point F, or the focus, and another light ray goes to the optical center. As you can see in this one, these 2 light rays are actually parallel, so they are not going to meet, and the image is formed at infinity. So we cannot really find the position of this image in this diagram, but we need to know that's highly magnified. it cannot usually be found out in your laboratories. And finally, for the last case, the object is in between point F and the origin. I haven't mentioned the origin over here, but this is the origin. Now, the object is over here. One light ray goes like that and converges through point F, while the other light ray goes through point O. As you can see, these two light rays are diverging. Hence, they're never going to meet unless you draw a line backward. Let me just show you that. Yeah. So the light rays were moving like that. Yeah, like that. Now these light rays have a big distance between them, and they're actually diverging from each other, which means they're never going to converge. Now what we have to do in this case occurs is we draw two lines backwards. This will be a dotted line, mind you, and the point at which it converges is where the image is formed. As you can see in this case, which is a special case, the image is formed on the same side as the object, and it is erect. So this image is actually the only case where the case is virtual and erect. So the nature is virtual and erect. Now P, which is NPSP, stands for position, which is to the left of F, and size, it is enlarged, as you can see, compared to the object. Now thank you so much for watching this video. If you have any questions or any suggestions for the next video, leave a comment down below. Thank you.